Hi, this is Dr. Shahriar Hussain again. Today we will discuss an unsupervised machine learning algorithm and use the scikit-learn machine learning library. The concept I will discuss is called clustering. The specific algorithm that we will look at is called the k-means clustering algorithm. We will discuss what it is and then we will write a Python program. Knowing what it is more than half the work done. After that, the code will be pretty straightforward. Suppose you have a data table. A clustering algorithm will tell you which data points or which rows are in the same group. That is, rows that have similar features will be in the same cluster. The purpose of the k-means clustering is to discover k groups of objects in data. If k is equal to 2, you are looking for 2 groups. If k is equal to 3, you are looking for 3 groups. If k is equal to 4, you are looking for 4 groups or clusters, so on and so forth. Consider that we have this table of data. It has 3 columns or features or attributes. It has 10 objects or rows. Now, notice that some of the rows have larger values compared to the other rows. The k-means clustering algorithm with k equals 2 will be able to separate objects into 2 groups. These rows will be in one cluster. Let us say that these points will be in cluster 1 and these rows will be in cluster 2. Notice that objects in cluster 1 have larger values in their features. Objects in cluster 2 have smaller numbers in them. That is, in clustering, rows that have similar features will be in the same cluster. In real data, all the features might not have all large values or all small values. Some features in the same row might be small, some features in the same row might be large. Also, there can be many features or columns in your data, making the data more complex to create groups manually. Furthermore, it is difficult to find groups or similar rows if you have too many rows. Finding groups might be difficult even if you only have several hundred rows. Anyway, I will use this small data table in a Python program to keep the discussion simple. You could have a large data table. The code part of the code will remain the same. The k-means clustering algorithm is scalable, which means that the algorithm works very well with large data tables. If you have a large data table and if you need to find groups of objects from the data, the k-means clustering algorithm should give you the clusters quite fast. The input of k-means clustering algorithm is the data and k, which is the number of clusters. That is, you are giving the data and you are saying that you want to discover k clusters. The output of the k-means clustering algorithm is a cluster assignment for each row. That is, for each row, the algorithm will give you a cluster assignment which is an integer. For this data table with k equals 2, these rows will be in one cluster. Therefore, all the assigned cluster IDs for all these similar rows will be the same. Here it is 1. That means all these rows belong to cluster 1. Against these rows, another cluster ID will be given. Let's say the cluster ID will be 2. This new column has the output of k-means clustering with k equals 2. The cluster assignments could be different as well. For example, the k-means clustering algorithm could say that these rows belong to cluster 0 and these rows belong to cluster 1. Notice that these two sets of outputs are the same. Just the cluster name 1 has changed to 0 and cluster name 2 has changed to 1. In K-means, it does not matter what integers are used in the result. What matters is, are similar rows in the same cluster and dissimilar rows in different clusters? A clustering outcome is an array of length equal to number of rows you have in the data. Against a row, there is exactly one number representing a cluster ID out of k clusters. I have a more detailed video on the K-means clustering algorithm, its theory, and the implementation of K-means in another video. I'll provide a link of that detailed video in the description section below. In the workshop, I focused on the Python coding part for K-means clustering algorithm. Let us go to my computer for the Python coding part. I am writing my code using Google Colab. I will use scikit-learn machine learning library where the state-of-the-art clustering algorithms are already available. The scikit-learn package has the name sklearn in Python. If you use Google Colab, it is already installed there. If you use Jupyter Notebook or regular Python, you need to make sure that scikit-learn is installed on your local computer. Here's the pip command for installing scikit-learn and integrate it with your existing Python on your computer. It's pip install sklearn. If scikit-learn is not already installed, the command will install and integrate scikit-learn with Python. On this terminal, it is already installed. Let us write the code. I will import the k-means class from the cluster directory of the scikit-learn or sklearn library. After that, I'll be able to use the k-means class, which has the necessary functions for the k-means clustering algorithm. I will also import the NumPy library as np. Then I will create the dataset. The dataset will be precisely this one. I will hardcode the data here by typing the numbers. I am creating a NumPy array that will contain the 10 rows and 3 columns of this data table. That is, this variable named data contains the dataset. The variable data is a two-dimensional NumPy array. This two-dimensional array will hold this three-dimensional data table of 10 rows. Such artificially manufactured data is generally called a synthetic dataset. Synthetic datasets are used to test new algorithms. In our case, we are using this synthetic dataset to check how the k-means clustering algorithm behaves on this dataset, for which we already know the result with 2 clusters. In an ideal case, you will read your data from a CSV file or a TXT file and keep the content in the data variable. Now that we have the data in this variable, we can use the k-means class to find k clusters. For this example, we will find 2 clusters. In real-life data, you can find 2 clusters, 3 clusters, 4 clusters, or any number of clusters that you need for your analysis. The number of clusters is provided as a parameter, n_clusters. We set n_clusters equal to 2 because we want to discover 2 clusters. After providing the parameter, we access the function called fit, where we provide the data as a method parameter. Practically, this is it. The clustering will be performed. To capture the entire clustering model, let us write km equals to the left of this part. After the code is executed, up to this point, we have our clustering model and the result in this variable named km. Km contains many things, but for now our interest is the clustering result, that is, the cluster assignments for each row. Since we have 10 rows in our data, The clustering assignment should be a one-dimensional array of 10 cells. That one-dimensional array will represent which row of the data belongs to what cluster. There is an attribute inside KM that captures the assignments. The attribute that holds the assignments is named labels underscore. There is an underscore after the word labels. We can print the assignments via the print function. In print, we state km.labels underscore. That will print the assignments of all the data points. That is, this labels variable holds labels of all points or assignments of all points. Notice that the rows with larger features are in cluster 0 and the rows with the smaller numbers are in cluster 1. If you run the code several times, you might find that sometimes the zeros are ones and ones are zeros. But you will always find that the rows with the larger numbers are in one cluster and the rows with the smaller numbers are in another cluster. Here in this example, one cluster is called cluster 0 and the other cluster is called cluster 1. We asked for 2 clusters, so we received 2 cluster labels 0 and 1. If we had asked for 3 clusters, we would have received 3 labels 0, 1 and 2. In the description section below, you will find a link to this code. Please go ahead with some practice. Please make sure to change the data. Use more columns and more rows. I'm sure you will find exciting things with your own datasets. There are several limitations of k-means clustering algorithm. Your data table cannot have strings or categories. Data must be all numbers. Another limitation is you have to play with k, the number of clusters, to see if you have meaningful results. Researchers have for many years argued that users providing the number of clusters is a limitation. In modern data science, being able to provide an expected number of clusters, k, is considered a strength because the user has some control in generating meaningful results. In the next part, we'll see how we can visualize the data and the clusters that the k-means clustering algorithm has produced. See you in the next video soon.